Hi everybody! So in today's video we're going to take a look at some cool calculator stuff that you can do that we haven't learned up until now, but that's going to prove very useful. So you're going to definitely need your graphing calculators out while you're watching this video so that you can play along and make sure you can push the buttons with me correctly. The first thing that you need to know is that you can actually take a derivative on your calculator. For example, if I told you that f of x is this function, and I said find f prime of 2, your calculator will actually do this for you. Now, this is kind of tricky because this only works for specific values of x. So this would not help me find like f prime of x, where I wanted a formula. It's only going to tell me the answer when I want the derivative at a specific number. So here are the buttons you're going to push, and see if you can follow along with me. So first, we're going to push the math button, which is right here on your calculator. I don't know if you can see, right here below the alpha button. And if you scroll down, and you don't have to scroll down every time, I just want to show you, it says in option 8, numerical derivative. That n means the derivative at a specific number. N is for number. So first you're going to push math, and then you're going to choose option 8. Now to do that, you don't have to scroll down every time. You can literally just hit the number 8 and it'll select it for you. Now on your screen, you're going to see this pop up. You need to fill in your information. So we are trying to find the derivative with respect to x, so d over dx. Now this button right here next to alpha types in an x for you. Inside the parentheses, you're going to type in your equation. So you would type in 3e to the 2 sine of x, finish your parentheses for sine, then push the sideways arrow to get out of the numerator, and then plus 7. The last thing you need to fill in is evaluated at what x value. You'll remember our notation for evaluated at has that line, and then you write down what you're plugging in. That's where you fill in that you're plugging in f prime of 2. Then you're going to hit enter, and it tells you your derivative. Now you're always going to round to 3 decimal places, so the nearest tenths, hundredths, thousandths. Okay, that's kind of a cool thing that your calculator can do. Now the next cool thing that your calculator can do is it can actually draw the graph of the derivative so that you can analyze it. Now this is really important because we know how to analyze the graph of the derivative. So if you wanted to, for example, okay, so you can graph either the original function to analyze it, or you can graph the derivative so that you can analyze it. Now we're going to start by looking at how we graph the derivative. So you're going to go to y equals, you're going to type in your equation, now it says here we want to look at where we're increasing specifically on the interval from 0 to 10. So I'm going to change my window to go from 0 to 10, and then I'm going to look at my graph. Now I'm increasing whenever my slope is positive. So I'm going to change my window a little bit because I can't quite see the top of this graph yet. Yeah. Looks like it's just going uphill the whole time. So if this is the derivative, where is the original increasing? Well, the original is going to be increasing whenever this graph is above the x-axis. So what I'm going to do is find this x-intercept. I'm going to go to calculate 0. I'm going to choose a number a little bit to the left, a little bit to the right, and I'm going to hit enter. which tells me that I'm going to be increasing from this x value all the way to 10. So I would say from 4.159, oops, this should be a closed bracket, to 10, my original function is increasing because the derivative is greater than or equal to 0. So I'm above the x-axis. Now that's great if you already have the derivative, but there is something cool that your calculator can do, which I'm going to show you right now. Let's say we wanted to graph this derivative. So we don't have the derivative equation yet, we're just going to graph it. Your calculator can actually do that. To graph the derivative, you're going to go to y equals, and you're going to go back to math option 8. And you'll notice it pops that d over dx situation up in the y equals. You would type in d over dx, type in your equation, but then here where you normally type in a number, you're going to type in an x. What that means is graph it for every x. If we go back to our graph now, this is the graph of the derivative. Now you'll notice the graph is taking a long time to generate, and the reason is because the calculator is actually calculating the derivative for all those different x's before it can graph it. So we can graph the derivative, it's just in this d over dx of your function thing, evaluated at, you just type in x equals x there. Versus here where we found the derivative at a specific number, so we typed in x equals 2 there. So let's look at some sample problems from old AP tests. The first derivative of the function is here. At which of the following does f have a minimum? Well, let's take a look. We're going to graph the first derivative. So sine of x squared, because I know that if I'm looking at the derivative graph, a minimum is going to be where my graph changes from downhill to uphill, which means from below to above when I'm looking at the derivative. So I'm going to go to Window, I'm going to go to Zoom 6. Let's see here. Oh gosh. Well, it looks like all these numbers are between 0 and 3, so I'm going to change my window to go from 0 to 3 so that it's not quite so overwhelming. So it looks to me like the only place where the graph of the derivative changes from below to above is right here, which means I'm going to go ahead and calculate that 0. So from here to here, it's 2.507, which is going to be this answer. So that's the place where the original has a min. So the original has a min where the derivative changes from below to above, which is what I just found. Another sample AP question would be, the graph of this guy changes concavity where? Well, you can't actually get concavity by looking at the original graph, but we can get the concavity by looking at the derivative graph. So what I'm going to do is I'm going to graph the derivative. So I would hit Math option 8. I want to graph the derivative of x to the third plus 6x squared plus 7x minus 2 for all x's. Now I know that my concavity is going to change where the slope of f prime changes directions. So now I'm looking at the graph of f prime. The slope changes directions there. Downhill changes to uphill. So I'm going to go to calculate my minimum, because this is a low point on this graph. So my left bound is here, my right bound is here. It's going to be -2. 1.9. Did I type something in wrong? X cubed plus 6x squared. I might have also just typed, oh, I forgot the cosine. Got it. That's the problem. Okay, let's try this again. Let's go back to our graph. There we go. That's much better. So I'm going to go to calculate my minimum again, because I typed in my equation wrong last time. I apologize. Here to here. I get -1.89, which is right here. So as you can see, your calculator can do some pretty neat stuff. Most importantly, probably, is the fact that it can actually graph a lot of stuff for you, including make the derivative graph for you, because we know how to find a lot of information using the graph of the derivative. We've practiced that a lot, looking at the graph of the derivative and getting a bunch of info. So the key here is to recognize and to know that the concavity changes when the derivative graph changes slopes. As long as you know that kind of information, your calculator will do a lot of the work for you. All right, guys, thank you so much for watching. Have a wonderful afternoon.